Здравствуйте, Лаура.
Здравствуйте, добрый день, коллеги.
Здравствуйте, Зулайка, Таныс.
Как переводчики как будут сегодня? Ой, а где у нас функция перевода? Так. Нет, сейчас подождите, давайте заново подключимся сейчас, пока завершим и заново сейчас. Добрый день, коллеги. Скажите, пожалуйста, кого переводчиком назначить?
Здравствуйте, сейчас я начинаю, Зулайха.
Хорошо, тогда... Так, Хари здесь? Нет еще, да?
По-моему, нет еще.
Танара, здравствуйте, мы вас видим. Вы вчера не присутствовали.
Здравствуйте, Лаура. Я решила, вчера услышала, что было очень интересно, и нашла время, чтобы сегодня подключиться, хотя бы буду, может, с перерывом, но буду слушать вас.
Раньше думали, что мы что-то неинтересное вам предложим, да? Будем знать.
Дело не в этом.
Ладно, шучу.
Очень приятно вас видеть.
Понимаем, да. Хорошо, сейчас ждем Хари. Сегодня как раз будет по AKI.
По KI будут, а с Минздрава есть кто-нибудь, да? Вы пригласили?
Нет, мы только для Казгидромета проводим. Это обучение. Для Минздрава и Минэкологии у нас, по-моему, в апреле, да, по графику или когда, будет анализ НПА и вот эти предложения по переходу на IKEA.
Спасибо, хорошо.
Hello, Harry.
Hello. Hello.
Morning.
What is the corona situation there at the moment? Is it growing or stable?
When it comes to Astana, it's not pleasant situation actually. We have some restrictions in public places.
Okay.
And we are not, and it's not allowed to organize mass meetings.
Yes, it's the same. It has been almost 1 year the same in Finland. So no mass gatherings. But how many cases do you have per day?
I didn't follow that information, but
Okay.
it's being like posted daily, on a daily basis.
Okay, but is it growing or stable or going down?
It's growing, but not at that speed that was in 2020.
Yes, yes.
In spring and summer 2020, it was very, the speed was very high.
Yes, yes. Yeah, let's hope that it goes. This year is the last year. Let's hope so.
Let's hope so. But some
do you have
environmentalists,
I'm sorry.
some environmentalists say that due to the COVID, now the air is cleaner.
Yeah, that's also, we have made some studies on that in of course here in Finland, but also globally in some, like China.
Yeah.
1 year ago, the drop was, or the cleaning of the air was quite dramatic, but also in other places in globally. So you can see it. You can see clearly, of course, because we are utilizing heavily the satellite information for air quality studies. So that's quite dramatic. But after the restrictions come, when you do not have the restriction, the situation is worsening also very rapidly. So it's only a short of time that it's cleaning the air.
Mhm.
I see.
I don't know, which one do you want, the COVID or clean air? You can select. But in Europe, if the estimate is that for bad air quality, it's 400,000 people dying every year for bad air. So, but last year it was close to 800,000 people dying for COVID. So I don't know which one to choose. So COVID is nevertheless, I believe it's better not to have that.
So the number of the people dying from the COVID is less than
No,
it's
it was double last year.
It's high. Mhm.
I see.
In Europe, I mean.
Okay.
In Finland, because the COVID, we have mitigated the COVID very well. So our situation has been quite good all the time. So we don't have so many. What is the total number? It's below 1,000 or something like that. And Finnish estimate for deaths due to the air pollution is something like 3,000 per year or something like that. So we had more from bad air than COVID. But I don't know, these are only numbers.
Уважаемые представители Казгидромета, добрый день еще раз. Кто такой Талгат? Пожалуйста, напишите свои имена. У нас, по-моему, на этот тренинг Талгат не записывался. Азамат Кавазов, да? Нурмухамед, да, был. Ортпаевой нету здесь. Айнура Ортпаева, где она? Вчера только она задавала вопросы. Другие почему-то молчали. Интересный вопрос задавала касательно летучих органических соединений. Манзура, Ольга. Кто такой Талгат? У нас же, насколько мне известно, Талгат не записывался на тренинг. Ольга, у вас замена людей или, может, уточните? Вот у нас Абаев Нурлан, Кавазов Азамат, Берик Ахмед записаны. Кто такой Талгат? Ольга, вы можете, пожалуйста, уточнить по представителям Казгидромета? Кто будет, кто не будет? У нас уже время, по времени должны начинать уже. Ольга, вы нас слышите? Так. Так, Берик, Ингар, Мансура, Айгерим, Талгат, Ольга. Смогулова Айгерим, это тоже ваш сотрудник, да, Ольга? Наверное, может, вы уточните что-то, Ольга? Нас не слышат или что?
Магулова Айгерим – это наш сотрудник. Берег, я думаю, фамилия тут не написана, но тоже наш сотрудник. Наши сотрудники сейчас подключаются, у Ольги нету.
Ольгу я тут вижу.
Видите, да?
Да, а Талгат это кто?
Талгат вот я не знаю. А Усманов, это наш Талгат, тоже наш сотрудник.
Ясно. То есть вот те участники, которые вчера были, сегодня не будут участвовать, да? Азамат Кавазов.
Ну, пока вот нету, кто подключился.
Ну, вообще у нас как бы по плану предусмотрено так, что участники будут проходить 3 дня обучения, потому что они же связаны между собой темой. Так, Ортпаева Айнур подключилась.
Если Ортпаева подключается, вы можете пока начинать. Сейчас остальных не заберем.
Хорошо. Тогда начнем. Добрый день еще раз, уважаемые представители Казгидромета.
Здравствуйте.
Уважаемые Хари, наши партнеры из Кыргызстана, наши переводчики. Сегодня мы продолжаем воркшоп на тему мониторинга качества воздуха в странах ОЭСР и как этот опыт применять в Казахстане. Международный эксперт Хари Питарила, он является экспертом Финской метеорологической службы, института, точнее. Вчера у нас была первая часть обучения, и сегодня мы продолжаем. Программу мы ранее вам отправляли. У нас будет с 12 до 2 обучения, потом с 2 до 2:30 будет перерыв. То есть у нас 2 перерыва предусмотрены. И сегодня у нас продолжение, второй день. Слайды у нас будут на русском языке демонстрироваться. Перевод вы можете снизу вот выбрать, какой вам удобный, хотите на английском, хотите на русском. И вопросы, вот вчера да, международный эксперт говорил, что можно будет задавать в ходе, или можете записывать, как вам удобно. Тогда предоставляем слово Хари. Хари, пожалуйста, вам слово.
Okay, thank you. Good morning, good afternoon. Maybe before to go to this day's agenda, so there was one question yesterday concerning the benzene measurement. So the number of the stations needed to monitor benzene was it in Astana or something like that? So I believe the population of Astana is a little bit over 1 million citizens. So as I already yesterday replied, so I don't know the pollution levels for benzene in Astana. So because the number of the station, it depends both the pollution levels and how many people is exposed to the concentration. So basically, when consider to start monitoring some pollutants, so my recommendation is first to make this kind of small campaign or study, this kind of indicative measurement campaign. So, and it could be organized quite efficiently or with no major costs for benzene with passive sampling method. So that would be my first recommendation, to organize this kind of 1-year measurement campaign to benzene with passive sampling. So I can give a guidance on that if you are interested. But nevertheless, let's assume that the benzene levels in Astana are high. So then it would be, if there is 1 million people living in Astana, so it would be like 4 stations to benzene.
Я извиняюсь. Я извиняюсь. Sorry, Harry. The question was related to Almaty city.
Almaty, okay. In Almaty,
Yes.
there is 1.5 million people, or how many people? What is the citizens of in Almaty? Is it 1.5 million in Almaty? So then it's Almaty.
Официально, возможно, 1,5 миллиона, но если по факту, смотри, где-то 2 миллиона, наверное.
Up to 2 million. So it's a bigger city than Astana. So, and might be, I don't know, might be even that the pollution levels are bigger. I don't know. It's like a, okay, but nevertheless. So then in Almaty, I believe you need at the minimum 5 stations for benzene monitoring if the concentration levels are high. As a comparison, I can give the number for Helsinki municipal region. So there is at the moment there is 7 stations for benzene measurements in Helsinki municipality or Helsinki metropolitan area, I mean, and there is something like over 1.5 million people, I believe, or something like that. Nevertheless. But the 5 would be minimum. But as told, I don't know what are the concentration levels. What is the pollution level? You should that should be first somehow estimated, and after that give the final number. Is there any measurements on the benzene?
Yes, Harry, we can give you detailed information on the current status of air pollution in Almaty.
Okay, for the benzene also. POCs. Okay, but that was like a rough estimate, let's say so. Yes, for day 2. So basically, we discussed yesterday about the importance of the quality of the measurement. Yesterday, and one very important part of the quality assurance of any air quality network, if it's big enough, or national air quality monitoring is a national calibration laboratory. So that will be one of the topic. I will start with that, and then there will be today we will discuss about this air quality index. I have understood that that's one of the major issues for you. So there is a part of air quality index in today's presentation. What kind of index you asked about the European index? So I will have a explanation on what kind of European level index there is, and also I will introduce the Finnish air quality index, because we have our own, and many European countries have their national indexes as well. So I will discuss on that. So what is the differences and why the situation is such, and also some other indexes like the US index. I have understood that you are considering the US air quality index. So something about that. And we will close today on the source apportionment issue. So that's a very interesting topic, and I believe that could be also discussed whether it should be or whether it could be applied also in Kazakhstan. Okay, so the first topic was the concerning the quality control, quality assurance. What is the role of calibration laboratory in that process? Next one. So as I told yesterday already, the quality issues is also highlighted as an important part of the air quality monitoring in the air quality directive. So it's a central part of the directive that you have to know what is the uncertainty or reliability of the measurement data that is used in air quality management. So that's a very core issue of the European Union air quality directives. So in the directives it's said that member states and the air quality measurement network, they have to ensure the accuracy and the quality of the measurements and demonstrate and prove the compliance of the measurement data with the data quality objectives that is set given in the directives. I already introduced those data quality objectives yesterday, if you remember the tables. So there is a different data quality objectives for different levels of measurements. So the data quality objectives are higher for the so-called fixed reference type of the measurements, and they are a little bit lower for these indicative measurements or this sensor type of the measurements. But whatever is the level of the measurement, there is already data quality objectives in place. So whatever measurement you are doing on regulatory purposes, you have to ensure the quality and demonstrate the quality of the data that you are producing and using in air quality management. So that's a basic principle in the directives. So the directives are giving some principles how to do it. So basically the first principle, and very important, I mentioned that yesterday quite often, so that all of the measurement in the country, in the city network and the whole Europe, they have to be traceable so that you can demonstrate the quality. So that's the basic principle for all of the measurements, whatever measurements you are doing. And the traceability is then demonstrated so that in the measurements you are utilizing the harmonized and commonly agreed standard for the testing and calibration laboratories, and also for the measurements itself. So either to use the reference method, or if not reference method, so then you have to demonstrate the equivalence of the measurement method that you are using against the reference method. So that's the one basic principle also. In addition to this traceability demand, so there is also, because it's not only the measurement equipment, but it's also the data quality, the quality management process itself. So you have to have established quality assurance, quality control system for your measurements in place. And that's not only for the laboratory, that's also for the field measurements. So it covers the whole chain of the measurement process, that you have to have the quality control, quality assurance process in place, so that the accuracy of the continuous measurements is ensured. Basically, it's stated also that because it's understood that the measurement, the field measurements are done with the different organizations. It can be like a national organization, FMI in Finland, or it can be some city, local authority. Like here in Finland, we have 35 of those city organizations that have their own measurement networks. And it can be also like private industry. Like here in Finland, we have a couple of those industry operated air quality monitoring networks. So it doesn't matter who operates the network, the quality assurance, quality control system has to be checked or ensured by this national calibration laboratory or national reference laboratory. So the national reference laboratory is like authority to check and assess that the quality processes are in place in all of these networks that are operating air quality measurements. And as told, it's not only the equipment itself or the calibration practices. Those are of course very important for the quality control, quality assurance, but the quality management process has to cover also the data processing and data collection and data reporting and data interpretation. So the whole chain of the air quality data from the in situ measurement point until the data is received by the user. So whenever in the process you are doing some manipulation or whatever for the data, there has to be this quality control in place. And as told in the Europe, because yesterday I discussed that the quality of the data has to be at the same level and demonstrated in the whole Europe. It doesn't matter who makes the measurements, what country or what network. So it has to be equivalent. So that's why this quality assurance program has to be European, covering the whole European Union, and that's why there is this kind of quality assurance programs linked to the European Union, the whole European Union networks, and that's why these national reference laboratories, they have also established this kind of network of the national reference laboratories to ensure that all of the countries are doing it in the same way. So those are the main principles for this. Next one. So it was stated in quite many places in the directives that there is a requirement and duties for the national air quality reference laboratory. So let's talk a little bit about that also. So there is the requirement in the directive that all of the European Union member states, they have to appoint authority called National Reference Laboratory within their country. So it's a mandatory requirement in the directive that all of the member states, they have to have a national reference laboratory. And of course, because there is this kind of mandatory requirement to nominate it, there is also requirements for the laboratory. Of course, the first requirement, it's quite evident that because it's the highest level to ensure the quality in the country. So of course, it has to be the accredited laboratory. So the methods that the National Reference Laboratory is using for the work has to be accredited. And this National Reference Laboratory, as already told, it should participate in the coordination, in the European-wide coordination of the air quality assurance programs. So it has to participate, or it's the link to the traceability chain, and it has to participate the European-wide intercalibration programs, for example. And also it's the authority in the country that also like defines or give guidance for the reference methods that's the to be used for the monitoring, and also it's the body in the country who is responsible for demonstrate the equivalence if the member state is using the non-reference method. So it's the role of the National Reference Laboratory to demonstrate the equivalence. So it organized this equivalence test within the country, and after the reference laboratory has demonstrated it, those non-reference methods can be officially used for the air quality monitoring within the country. This question. So it's like a member state issue to demonstrate the equivalence. And very important part of this national quality management process is that this National Reference Laboratory organized intercalibration campaigns within the country itself. And it is also part of the accreditation that the calibration laboratory has. So there is also like regulations how often this intercalibration tests has to be conducted. So there is a requirement that at least every 3 years the national reference laboratory will participate EU union-wide interlaboratory comparisons, and those are organized by joint JRC in Italy. So and of course, if you are not doing good, so there is consequences in that. As told, there is also this kind of European-wide network for national reference laboratories set by the European Commission. It's called Aquila. It's a very important part of this quality assurance for air quality monitoring in Europe. So it's like an official network, because there is a nomination and all the European Union and national reference laboratories are part of that work. So it is basically the body who gives the detailed guidance and technical documentation how this quality work should be organized in practice in Europe and national. Of course, there is always different kind of ideas or practices in each member state. So this Aquila is the place that different countries are discussing and getting the consensus how to do the work, so that it's harmonized over to Europe. So this is like a little bit pictures on Finnish National Reference Laboratory. Finland, I'm a little bit proud of it, because we are, let's say, one of the good ones in this work, maybe even one of the best ones in this quality issues of air quality monitoring. We have been also, our previous head of National Reference Laboratory, Jari Valteen, was the president of the Aquila many years before he retired, and we are very actively participating the work and the development work of the whole quality issues for air quality monitoring in Europe and also in globally. So this is some of the activities or responsibilities that this National Reference Laboratory is doing. So of course, as told many times, it's the one who keeps the traceability of all of the measurements within the country. So it maintains the traceable calibration services, offers that for all of the measurements. So in practice, all of the measurements, all of these 35 air quality operators, they come to this laboratory every year to get the traceability for the measurements. So in practice, what they are doing, they are coming with the field or transfer calibrator to this laboratory, so that this transfer calibrators are calibrated against the primary methods in the National Reference Laboratory. And of course, it's a constant work. So all the times, these calibration methods that this laboratory maintains, they are developed also. So our laboratory is actively participating this calibration method development and this European-wide and global different kind of standardization work and so on. So it's also partly a research laboratory trying to develop new and better methods for the quality, to ensure the quality, and of course participating different kind of working groups and so on. As told, also the traceability of the measurement is ensured, so that this calibration laboratory, it doesn't only provide the calibration services for all of the network operators in Finland, but it also organized this intercalibration campaigns in Finland, and also it participate the intercalibration campaigns that are organized by this joint JRC for the whole of the Europe. So that's how it's demonstrated the traceability. One very important part of the work of this kind of laboratory is that because the local network operators, they have to, of course, have the quality control systems in place, and they need support and guidance for that. So this National Reference Laboratory organized different kind of trainings for the local network operators, and also it conducts audits for the local networks and even to the local measurement stations. So our reference laboratory basically regularly conducts quality audits to the individual stations that are operated by some network, and also for the network itself. So how the work is done there, the quality assurance, quality control work. So there is a lot of different kind of duties, very important duties that enables that we have a harmonized quality for all of these 150 air quality monitoring stations over Finland, operated by 35 different operators. Yes, so that's shortly the duties of this laboratory. Next one. So, as I believe already mentioned, so our laboratory, it's not only National Reference Laboratory of Air Quality according to the directives, but it's also Finnish metrology laboratory for air pollution, or for these different parameters, the mole of NO2 or those, because the metrology is defined a little bit differently than the EU air quality directive. So we are part of this metrological global network. Of course, we are not the FMI, Finnish Meteorological Institute, is not the main metrology institute in Finland. In Finland, it's MIKES, the metrology institute, who is responsible for the mass, the kilogram, or the meter, or this kind of technical parameters. But we are like subcontracted by MIKES to take care of some of the SE units related to the air quality. So we are part of the MIKES as a Finnish meteorological Finnish metrology laboratory in a way. So we have a double role in this way. We are also the highest in air quality. We are the metrology, and we are also the this European Union reference laboratory. And that's why we are not only participating the European coordination and development and intercomparison, but we are also participating this global work because we are part of the metrology family also. and that's why FMI is also very actively participating the global standardization. You referred or asked why European Union doesn't recognize the US standards. So no, we are not recognizing the US standards. We are recognizing the global standards because we are not under the United States. Okay. In practice, of course, main part of the work of this National Reference Laboratory is to provide this calibration services to the Finnish local air quality networks. With the calibration service, you provide the traceability for the networks. So of course, for this, all of these calibration services, you have to be the accreditation in place, and of course the accreditation is defined very clearly. What does it cover? So, and these are basically now defining for example, the calibration ranges that FMI reference laboratory provide. So it doesn't, of course, you understand that this kind of calibration, it's not only the concentration, because yes, sorry, yeah, next, sorry, I didn't remember to say it. Yes. Okay, sorry. So that this is the practical work, so that of course the laboratory, to ensure the quality for all of the networks, it provides the calibration services, and the accredited service it covers very precisely defined ranges for the work. Here is like examples of the gas pollutants, but not only the like concentrations for the different pollutants, but a very important part of to be able to ensure the quality of this kind of measurements, because it's always question of the not only the concentration, but there is also, because these devices do the analysis from the airflow. So there has to be also very precise airflow calibration in place. So and basically, of course, in our case, the basic work is covered by the Finnish governmental budget, but this calibration service itself, because it's not only the authorities that are utilizing these services, but it's also the private network operators that are using these services, so they have to pay for this calibration service itself. Training and this kind of overall guidance is given free of charge, but the calibration itself, it's the networks have to pay for that. So it's a service. For this calibration, there is of course different kind of method. That's also part of the quality control of the calibration laboratory itself. Of course, it's very important that the calibration laboratory itself have a very good quality control system in place. So that's why there is many different methods in use for the calibration. So you can also do the inside calibration laboratory intercomparison for different methods. And for different parameters, so there has to be a different kind of calibration methods in place in the laboratory. So this is I'm very sorry. This triangle is a little bit small, and I noticed that the text in the triangle are not couldn't be translated. But basically, this is quite important triangle, because if you remember, I had same kind of triangle for the measurement methods, basically describing that different kind of stations have a different level of the quality. So now this triangle is basically the same, but including the traceability of the measurement. So not only the stations itself, but also the whole process ensuring the quality of all of the measurements in the country. So and globally, basically also. As you remembered, in the triangle of the measurements, we had in the top, in the tip of the triangle, we had these kind of so-called super sites with the highest quality and highest costs. Then we had these reference stations using the reference methods in the middle of the triangle, and in the bottom of the triangle we had these low-cost indicative measurements with the lowest quality and lowest price. And that's the basically same here in this triangle. So in the bottom of this triangle we have the stations in the country, this 150 stations, all of these stations in Finland. and the quality of those stations are basically there in the lowest level of this traceability chain of all the measurements. And these field stations, they are using working standards to ensure the quality within the station measurements. So there has to be also this calibration standards in the station itself, and those are called as the working standards. And the uncertainty or the accuracy of these standards is of course bigger than in the calibration laboratory. Then to able to transfer the standard to the station, you need some kind of method for transferring the quality standard to the station level. So and that's called like a transfer standard. So that's basically in a European way, it's like a field calibrate or diluter. By that method, you are transferring the accuracy from the laboratory to the field. And of course, the transfer standard, it has to be calibrated against the certified materials in the calibration laboratory, the National Reference Laboratory in FMI, because they have the higher standard in the calibration laboratory, and those are the certified materials. They have the certified materials, and that's also more pricey. So it's not economic wise that all of these 150 stations would have the certified materials in each of the stations. So because it would cost enormous amount of the money. So that's why we have this highest certified materials only in one place in Finland, and that's the National Reference Laboratory. And of course, this National Reference Laboratory, so that the traceability is unbroken, it has to be connected to the national metrological traceability chain or the primary standards in a country. Luckily, as I told, these two parts in Finland are organized in the same way. So no, I'm still explaining. So both this national metrological metrology duties and standards, these primary standards, and also these certified materials are in the same laboratory in Finland, in FMI National Reference Laboratory, which is also the metrological laboratory. So in Finland, we have been organizing this. It's a cost-efficient way in our case, so that both of these are in the same laboratory. And this primary method in a country, they are of course linked to the global SI system. So it's directly traceable to the SI, the moles and kilograms and so on. So, and also in this tip of this triangle, it's the highest cost, and the bottom of the triangle, it's the lowest cost for the quality and the standards. So basically equivalence to this different kind of stations triangle. Okay, next. Okay, this is just this is just the example. Of course, as I told, the accreditation is very important because we are talking about the quality systems. So this is just an example of our accreditation certificate for some parameter. So, but let's next one. As I told there is different kind of calibration methods in use. In FMI calibration laboratory to ensure the traceability and to perform the calibrations. These are couple of basic methods that are in place in our laboratory and also commonly in this kind of national reference laboratories. So basically for gas pollutants, there is most often two main methods. So there is this kind of, it's called like a dynamic dilution method. So it's based on the, of course, you have to have the primary standards for each of the gas concentration, and then you, like with this this method, you have a diluter that is highly accurately you can change the flows with that, and of course you have to have the traceable flow measurements also to ensure that the flow meter is traceable itself. And this dilution method is then connected to the different kind of gas analyzers for the calibration. The another method is basically this kind of static injection method. There you have also these gas bottles, of course, providing this primary standards for each gas, and then you have this kind of chamber with the known volume that you can then vacuum with the pumps, and then you can put the known amount of the moles of specific gas inside, and then you have to have good enough pressure measurements and all of that to be able to have a traceable concentration of the specific gas to be measured by the analyzer. So that's basically two principal methods for this gas concentration calibration service. Ozone is of course a slightly different issues, because ozone itself, it's not like a primary pollutant, but it's like very reactive, and also it's not the direct emission from anywhere. So there is a different kind of method, and it's very pricey method. We are lucky that we have the primary standard for ozone calibration in FMI calibration laboratory. So here is the picture of that. I don't know, the price might be €500,000 or something like that, the price of this primary method. Of course, every countries cannot, it's not feasible that all of the countries have this kind of primary method for ozone, not even in the Europe. I believe in the Nordic countries, it's only the FMI, so some of the countries, they are coming to get the traceability from our laboratory, for example. I don't know whether there is, I believe there is none of this in the Central Asia. It might be that there is one in the Vnim in the Russia, but I believe that might be in the St. Petersburg, in the Vnim, this Russian metrology laboratory. I believe I recall that they have this kind of primary method for ozone calibration within their laboratory. I have visited there a couple of times, and we are collaborating with them very closely. But we have provided the traceability for the ozone calibrations for quite many countries, because we understand that it's very expensive to have this kind of equipment. Next one. Okay, here is some more methods for this calibration. So there is this gas phase titration method, one of the methods that is partly you have the gravimetry system for the gas standard needed for that. Of course, very important is the gas flow calibration method that is also traceable for the SI. units, and this you of course know and understand that now we are talking about very low gas flows that has to be provide a good accuracy. So it's quite also basically you cannot buy this kind of low calibration systems from shop. So we have, for example, built this system by ourselves in our laboratory and demonstrated, of course, the traceability of the systems, and it's also accredited system. So, and it's the highest standard also for this low gas flows in Finland. So it's primary standard for Finland for this low gas flows. And one system is the permeation method also that is used in our laboratory. So and that's also based on the gravimetry. So it's very important to have also very high accuracy gravimetry, as you can understand. So next, I believe there is a little bit more about this gravimetry or balancing systems. Okay, so it was. So this is basically the gravimetry system, because it's not only to have the microbalance in the laboratory. That's not enough to be able to provide the needed level of the accuracy for weighing or balancing the filters or balancing for the permeation calibration method, but because for the balancing, it's not only the filter in the balance, but it has to be also to be done in the regulated and known atmosphere. So because the humidity is affecting highly for the accuracy or the numbers, temperature, all of this ambient climate that the balancing is made has to be regulated and measured with the high accuracy, so that you can ensure also the result, the quality of the result of the gravimetry method itself. So this is only a schematic picture of our gravimetry method in our reference laboratory. Next one. This is some like a picture. So we have basically also built our gravimetry method by ourselves. Of course, it's based on the very high accuracy microbalance that we have not built ourselves, but it's a commercial product. But all of these chambers, the method itself, temperature, humidity, all of these regulators, and so on, is built by FMI in our laboratory. There is also some available on the market that you could use, and of course there is two different ways to have it. So either you could organize so that the room for the balance is regulated and monitored, but that's of course very costly, or you can have this kind of regulated chambers that you put the balance in. This is a pictures of because this is needed also for the particulate filter weighing this same balance. Next. Okay, of course, those were only the technical examples of the technical facilities that has to be in place to ensure the calibration and traceability for that. But of course, as I already mentioned, it's not only the measurement equipment itself, the characteristic of each instrumentation itself that is defining the total accuracy of the measurements. It's also the calibration chain itself and the accuracy in that. And you have to remember that each step of the calibration and traceability chain, there is a different accuracy that is like summing up at the end for the total uncertainty of the measurement. And it's not only the measurement chain itself, but it's also how do you manipulate or process or validate the data. That's also part of the total uncertainty of the specific measurement number. So of course you have to have all of these uncertainties that is summing up to the total uncertainty of the final data. So you have to calculate all of those so that they are included in the uncertainty. So in Finland, of course, it's FMI National Reference Laboratory who has made this calculation process to calculate the uncertainty of all of the independent air quality measurements in Finland. So, and we have trained the local operators how to use this uncertainty calculation method, so that part of the parameters for these uncertainty measurements are of course coming from the National Reference Laboratory, because that is part of the uncertainty of all of the measurements, but some of the parameters have to be, of course, are to be defined in the network operator, and also in the station itself, and also at the end in each of the single instrumentation that is used for the measurement, and of course the field calibrator and the gas bottles and everything. So it's quite a complex system to be able to calculate the total uncertainty of any measurement. So but we have the system in place in Finland so that all of this calculation is also done in a harmonized way in Finland, so that all of the individual measurement, the uncertainty calculation is done exactly in the same way. That's of course important, because as you remember, I told that all of these, basically all of the measurements, 6,000 measurements in Europe, should be comparable with each other. So that means that the uncertainty should be also calculated exactly in the same way in the whole Europe. This is just an example. This is something, because it's not a quite simple task to do it. So we have also trained not only Finnish network operators for this uncertainty calculations, but we have also trained a lot of other friends in different countries. For example, the city of St. Petersburg, because we helped them to establish the traceable calibration chain, build up the calibration laboratory there, and also we help them to define the uncertainty of each station in the city of St. Petersburg after the modernization of the network. And also some of the countries that we cooperated, we have helped in this issue. Next. Okay, this is just the example. I already told that, of course, we organize this kind of intercalibrations or comparisons in Finland, and it's a regular practice. So it's every, let's say, every 3 or 4 years we organize these intercomparisons in Finland. So basically it means, of course, we cannot do it at the same time in each of the networks and each of the stations, but our calibration laboratory goes to the field and visits all of the networks within 1 or 2 or 3 years. So it can be that this year it's like 5 networks, and next year it's next 5 networks, and so on. But within the 3-4 years, basically we do the intercomparison for all of the Finnish networks, and at the same time they are also making the audits for the measurements in all of these single networks that's here in the map all around the Finland. Heavy work. So we have done it already, maybe might be that 5th round is now ongoing, if I recall correctly. But of course, this COVID situation is making it a little bit tricky. Next one. Okay, maybe this is not important. This is just a list of this different kind of key comparison that we have participated in our laboratory globally and internationally. Usually when we are FMI laboratories always at the top of the results. So we are usually in the top of 3 or at least top of 5 in the global laboratories when we participate in this. Next one. So that was the global and European perspective, but we and now it's the European perspective. So we participate the global comparisons, but also the regional or European comparisons. So it's always in different levels. And the next one is the table for the next slide. Is the table for the European comparison. Examples only, not updated, not including the latest ones, but just the examples. That it's basically, it's of course this comparison is always for specific parameters. Next one. Okay, as already discussed yesterday, maybe the most important air pollutant is the particulate matter. And there is a requirement for PM10, PM2.5 measurements by the directives. And if you remember, the reference method for particulate in the directive that is now in force in Europe is the gravimetry method, if you remember that. So it needs a sampling to the filter, and the filter has to be very balanced in the laboratory. So that's tricky in a way, because it cannot, with that method, you cannot provide the real-time measurement for the dissemination to the citizens. So that's why most of the measurement sites in Europe, they don't use the reference method, the gravimetry method, but they use these other methods that provide real-time PM concentration figures. So it leads to the fact that member states that are using this non-reference method, they have to show the equivalence of those methods against the reference methods, and it's a member state that has to show the equivalence or demonstrate, and that's the requirement from the directive. So that's a very demanding and heavy work, because it's basically the demonstration. The only way to show the demonstration of equivalence is to organize this kind of equivalent measurement campaign. So it means in practice that you have a intercomparison measurement campaign with the candidate method or the non-reference method against the reference method. There is a standard for this, how to organize it. So it's always needed 2 pieces of each instruments, for example, and it's a defined number of the observations that has to be gathered for this equivalence demonstration, and they have to be scheduled also in different seasons, because it's the different seasons are different for the particulates also. And because the particulates, the particulate measurement, for example, it's very related to the ambient conditions. So basically for these non-reference methods, and even for the reference method, the result itself and the accuracy of the result is depending on the what kind of particulates you are measuring. For example, how much volatile organic compounds are in the particulate. So it's reflecting to the measurement uncertainty for specific method. So that means that we have to organize this equivalence tests in different kind of places if there is a different kind of particulates in place. So this is quite a heavy duty to do, and we have done it in different places in Finland. We have done it in the southern part of Finland, where is also sea salt is affecting the particulates. So in the Helsinki region, we have done this equivalence test, and we have done it also in the different other parts of the Finland. And I'm talking about, okay, it doesn't matter. But nevertheless, of course, we cannot do the equivalence for all of the equipments that are available globally, but we have done the equivalence tests only for those instrumentations that are commonly used in Finland. And here in the table there is, or it was the previous table in the slide that gives the different PM monitors that we have done the equivalence tests in Finland. So it's this commonly used PM methods, the French equipment, environment equipment, CREAM, it's a German one, SHARP, it's a Thermo Fisher US equipment, quite widely used in Finland, and then there is also a couple of other thermo electron equipments and other systems that we have done the equivalence tests. So in this slide, this is like an example of the results for the equivalence test. From the equivalence test, basically it gives two kind of information to be used or utilized for your measurements for the specific instruments. First, it gives basically the answer whether the non-reference method is equivalent or not. If it's not equivalent, it cannot be used for the measurement, for the official measurements in the country. Basically, that's quite vital. And this is an example that, for example, in Finland, we found out that some of the equipments, basically, they don't pass the equivalence test at all. And these are the red ones here. For example, this dust truck, it clearly doesn't pass the test, so it shouldn't be used in Finland for PM measurements. And it's also different case for different particulate size. So most of the other methods that are used in Finland, they pass the test for PM10. But there is some methods that pass the test for PM10, they don't pass or fulfill the criteria in PM2.5. And it's also dependent on the concentration levels, because in different okay, this is a little bit difficult to explain, but nevertheless. And another information that this equivalence test is giving to you, that in most, if not all, of this non-equivalent, non-reference method, you have to use this kind of calibration equation to correct your data if you want to use those methods for measurement. So it means that you have to apply this calibration equation to calculate the correct concentration levels. So this is not the calibration of the equipment itself, but it's a calibration coefficient for the specific brand that is used for the measurement. So the calibration correction is then for the measurement itself, but this is for the equipment itself. So this is very important because so after this equivalence test, all of the field operators has to use this calibration equation when they report the data, and also when they disseminate the data to the public, so that the data provided is the correct one and equivalent to the equivalent measurement method. Next one. Okay, I'm not sure. Oh, okay, that was a little bit about the equivalence test and how important it is. It's very important because the particulate matter is the most important pollution. So a little bit back to the Aquila, I said that the Aquila is a very important body in Europe to ensure the European-wide or harmonize the European-wide quality for the air quality measurements. So it's the network for air quality reference laboratories. So all of the national reference laboratories in the European Union are belonging to this network. So there is altogether 37 national reference laboratories in Europe. So there is more than the member states. So in some of the member states, they have more than one reference laboratory. But most of the member states, they have only one reference laboratory, like in Finland, it's the case. There is also some other participants in this Aquila work. So there is the World Health Organization, European Environmental Agency, and European Topic Center for Air and Climate Change are participating in this laboratory. So this Aquila harmonized the whole, also partly globally, and of course the whole work into Europe. Of course, this is the network for European Union, but nevertheless we have opened the door also for the non-member states, so they can participate the work as observers, because for Europe it's very important that our neighbors also have traceable measurements, and they are also comparable to the European Union measurements for air quality. So it's not only the quality work that we want to join our neighbors for the same family, but also we have opened the access for this non-member states, the neighbors, also that they can provide the air quality data, real-time data, and also the validated data to the European Union air quality database. So and we can also publish the data if they want to provide it to us, so they can be included into the European air quality portal also. So some of the countries in the Baltic that are non-member state, they have already joined the work, both the Aquila and this data exchange, like the Serbia or Macedonia, that we have helped in the work and helped them to be part of this work. And of course, the Turkey is very important neighbor for us. They have a very wide network for air quality, partly helped by the EU, and they are also participating in the work. And of course, this is also possible for you if you would like to be participating in the work. So I can help you to get contacts, and I believe that this Aquila and the European Environmental Agency would be very positive for example for you if you would like to join the work. Next one. Okay, this is not the important one. This is how it's structured. This is an old one. I just wanted to put it there because it was the Jari Valteen, head of our national reference laboratory, who was the president of this Aquila very many years, and very core expert in this European-wide quality work as a whole. Next one. Okay, this is just a little bit more what the Aquila does. So harmonize and supports the European Commission and the Joint Research Center in the work that they are doing. So it's like guiding and supporting both when the European Commission or European Union is considering the new directive, as I said yesterday. So that work has been done. So the Aquila is supporting that work, and also as already I mentioned, it's supporting the work for the quality chain and traceability and intercomparison work and so on. And also it's the like a European Union body to participate the international standardization work also, this global standardization work. So it's the Aquila who is the expert institution on behalf of the European Union for that work. And it provides a lot of advices and technical documentations and guidance and so on in this work in Europe. Very important work. Next one. As I told, it provides a lot of technical documentation and guidance. So there is a lot of this kind of documentation and guidance documents how to do the work correctly. And those are applied in the member state for the work. Next one. This is some practical examples. So there was different kind of intercomparison measurements and field work, and there is like a particulate sample intercomparison. I don't know how many tens of the samplers there were participating in this at the same time from different member states, and this kind of field campaign there was a couple of years ago. Already 10 years ago. It was, the time goes so quickly. So there was also this kind of campaign, so that there was this kind of mobile reference instrumentations installed in this kind of vans, and then those vans, it's like a round robin test. So these vans were traveling all around Europe and doing the measurement campaigns in the 17 different member states. So very practical work also. I believe this is the picture in the upper hand. It might be from our laboratory when they were doing these tests. Next one. Okay, maybe to say that there is basically for tomorrow, because tomorrow we are talking about dispersion modeling. So there is the same kind of network for the dispersion modeling, because that's another tool for air quality assessment, so measurement and modeling, and for harmonizing the measurement work, there is this Aquila and the quality of the measurement work. To harmonize the quality of the modeling work, that's also very important. You have to know the quality of your air quality modeling. So there is a same kind of organism also established in European Union, and it's called FAIRMOD. And that's also giving the guidance how to do the air quality modeling in different countries. That's a little bit more challenging work, because basically, for example, there is no reference models defined, but nevertheless, that there is no reference models, you have to ensure the quality of the modeling result. But let's come back to that issue tomorrow. Next one. Okay, this is the same picture I already illustrated yesterday. So this is the monitoring site. Let's go next one. And this is the same picture I illustrated yesterday also, how the quality is then transferred to the measurement site. So here is in this picture is now the National Reference Laboratory here under the monitoring station. So the calibration laboratory, the National Reference Laboratory, is the entity that gives the traceability to each of the monitoring site through the field calibrator. That's the way to do it. You have the calibration bottles inside, nevertheless, for the span checks in the measurement site, but that's not enough to have the traceability. You have to have the traceability for this monitoring laboratory to the calibration, national calibration laboratory, which then gives the traceability to the international standards. So this is a vital element so that we can ensure that each of the monitoring stations provide traceable measurements. So if you don't have this link, then you don't have the traceability of your measurements available. And of course, then as already discussed yesterday, in addition to this technical link for the traceability of the measurements, you have to have also the validation procedures in place. Next, okay, I believe this was enough. I have still 10 minutes before the break, but I maybe if there is some questions or discussion points, because I believe it would be nice to have a break before we go to this air quality index topic. That's a totally different topic. So is there any questions? Is there anybody online still?
Yes, Harry, we're here.
Нет вопросов.
Okay, is it okay to have the break now?
Yes, we can have the break now, if it's logically okay.
Yes, it would be. It would be okay for me. So let's have a half an hour break.
Уважаемые представители Казгидромета, получается сейчас на полчаса перерыв. Мы с вами в 2 встречаемся, да?
So is it agreed? Okay. Okay. See you.
See you.